Hey guys, and welcome back to Chemistry 1032 instructional videos. I am your host, Dr. Russell Betts, and I'll be guiding you through this portion of the lecture. Chapter 3.5, The Mole, Counting Atoms and Compounds. Now, in our life, we have words that mean numbers. Dozen, that's a word that means a number, means 12. Gross, that's a word that means 144. Ream means 500. And we're familiar with these words. We use them every day. We kind of don't even think about them really because they're so ubiquitous, if you will. In chemistry, we have a word that means a number as well, and that word is the mole. The word mole means 6.02 times 10 to the 23 anything. All right, so in chemistry, 1 mole of atoms, say, is 6.02 times 10 to the 23 atoms. 1 mole of a molecule, say Tylenol or aspirin or something, is 6.02 times 10 to the 23 molecules of Tylenol or aspirin or whatever. Okay? And this number is also known as Avogadro's number. So that's just what we call it. Avogadro is an Italian physicist who discovered this phenomenon, this number. So keep that in mind, that it's just a word that simply means a number. Now, 1 mole of an element has what's called molar mass. Now, molar mass is the mass of 1 mole of a particular element. For example, carbon has a molar mass of 12.01 grams per mole. That's the molar mass of carbon. So if I wanted 6.02 times 10 to the 23 atoms of carbon, I'd have to weigh out 12.01 grams of carbon. Okay, that's how we weigh out atoms. We weigh it out or mass it out using grams, using the molar mass. And every element has a different molar mass. Now, let's take a look at the periodic table. Here we go. Here's our periodic table. If you look, let me zoom in on a few things here. If you take a look, say at nitrogen. Nitrogen has a molar mass 14.01. Now here I'm gonna round that up a little bit. On your exams, I'll give you a periodic table. Just use the molar mass that's printed there, please. Most periodic tables, nitrogen is 14.01, carbon is 12.01. This particular one, they've increased it. They've got more significant figures. That's all. But please, on the exam, use the one I give you. So notice how on the bottom here, every element has a number. Boron is 10.81 grams per mole. Carbon is 12.011 grams per mole. These are how many grams it would take to have 6.02 times 10 to the 23 atoms of that element. And these are molar masses. All right? All right. Now, moving right along. We kind of talked about that already. Now, if you want to convert something from atoms to moles, very simple. You just use the conversion factor listed here, or, of course, you can use this inverse, right? You can use either one. Those are the conversion factors from the Avogadro's number and the molar mass. So let's just go ahead and crank out a problem. We're just going to use the dimensional analysis to do it. Very simple. How many mole of sulfur are in 4.5 times 10 to the 19 atoms of sulfur? So here, this is our given unit. And it's going to be 4.5 times 10 to the 19 atoms multiplied by something that puts atoms on the bottom. Remember, so they'll cancel, right? And then mole on the top, and that will give us mole of sulfur. Now remember, 1 mole equals 6.02 times 10 to the 23 atoms. So when we're plugging the numbers in, the number 1 goes on top. 6.02 times 10 to the 23 goes on the bottom. Grab up your calculator. 4.5 exponent 19. Divide all that by 6.02 exponent 23. And you get, let me just do this. Here we go. 7.48 times 10 to the negative 5. And that's how you do that question. It's just a basic straight-up conversion question. Let's try another one. Maybe you should pause the video. You guys can give it a try. Here we're going from moles to atoms. So you're simply going to do the question backwards. No problem. Let the units do all the work. Pause the video. Give this a try. All right, welcome back. So we have 0.25 mole of carbon dioxide. We're going to multiply that by something that will give us molecules. It says atoms here. That's a mistake. That should say molecules there. Sorry about that, folks. Put moles on the bottom and molecules on top. Remember, 1 mole equals 6.02 times 10 to the 23. Oops, make that look a little prettier. Number 1 would go here. 6.02 times 10 to the 23 goes there. Grab up your calculator, 0.25, multiply by 6.02, exponent 23. You get 1.5 times 10 to the 23 molecules. And that's how you'd solve that problem. Okay, now if you didn't get that, go ahead and just go back and do it again. They're not hard. Just a one-step conversion question. Just like converting inches to feet. You just have to know the conversion factor. Here's another one for you to try. Go ahead and pause the video again. Give this one a try. I'm sure you can do it. They're not really hard. Give it a go. Pause. Come on back. Okay, welcome back. All right, here we go. You have some atoms of silver here, yeah? So, we got 4 point... Whoops. I'm sorry about that, guys. I gotta fix this. I went too far, sorry. There we go. This is where we were. There we go. Okay, so pause the video. You guys give it a try right here, and then come on back. Okay, so we have 4.56 times 10 to the 23 atoms of silver multiplied by something that'll put atoms on the bottom, mole on the top, and that will give us mole of silver. Notice the atoms are canceling. 6.02 times 10 to the 23 and the number 1. Grab up your calculator. Notice how these questions are pretty simple once you start doing a few of them, right? And the answer is 0.757 moles of silver. All right, now I'm sure you got that right. If you didn't, go back and review the videos and come back and try this question again. I'm sure most of you got it right, if not all of you got it right. Pretty easy stuff. You guys are all pretty smart. Now, we've been working with things now, and we know the molecular mass of the elements, right? But most of life is not made of elements. Most of life is made of compounds. So we have to calculate the mass of a compound so that we can calculate the moles of a compound. Now, for example, H2O. Say we had 20 grams of water or something like that, and we wanted to know how many moles were in that 20 grams. Well, there is no water element on the periodic table. Water is a molecule. So we'd have to know the formula weight of water. And to do that, we'd have to calculate it. Now, first thing you have to think about is that water, the mass of water, the mass of anything really, is the sum of all the masses of all the parts. Think about a bicycle, for example. The bicycle is a sum, the mass of a bicycle, excuse me, is the sum of all of its parts. It's the sum of the seat, the frame, the wheels, the pedals. All these things add up to give you the mass of a bicycle. Same thing with water or any molecule. The mass of water, the molar mass of water, is the sum of all the molar masses of all the atoms. For example, it's 2 times hydrogen, right? There are 2 hydrogen atoms in water and 1 times oxygen. These are the constituent atoms that are making up the water molecule. And we look at the periodic table. Let's go there real quick. Take a look at the periodic table. Come on over here with me. If you're wondering what website this is, it's ptable.com. Pretty nice little website. There's the molar mass of hydrogen. Now I'm going to take it as 1.01 grams per mole. On the periodic table that I give you, that's what it will say is 1.01. So let's go back to where we were. All right. Now, it erased all my work, but that's okay. H2O, 2 times hydrogen. Hydrogen is 2 times 1.01 grams per mole. That's the molar mass of hydrogen. Oxygen. It's 1 times oxygen. I happen to know the molar mass of oxygen is 16.00 grams per mole. So multiply through 2.02 grams per mole plus 16.00 grams per mole. And if you add all that up, you'll get 18.02 grams per mole. So if I wanted to have 6.02 times 10 to the 23 molecules of H2O, I would need 18.02 grams of H2O. Remember, this is a mole. Okay? That's how you do it. If you had a molecule, you just have to add up its formula weight, and then the math to convert from grams to moles, from moles to molecules and all that, it's the same math. Pretty easy stuff. Okay? How many grams of carbon are in 3.2 moles of boron? Well, that question's obviously messed up. Carbon. How many grams of carbon are in 3.2 moles of carbon? The question as it was written was messed up because you can't have moles of carbon if you have grams of boron. That's just crazy talk. But it's carbon, so just make that correction in your notes, please. So we have 3.2 moles of carbon multiplied by something that will give us grams of carbon. That's the setup. Mole comes down here, and grams go up there. That way the moles are canceling. We look at the periodic table, we find that the molar mass of carbon is 12.01 grams per mole. This is from the periodic table. You can just look that up. So we put 12.01 up here, and the number 1 is down there. Grab up your calculator. 3.2 multiplied by 12.01 equals 38. 38 grams would give you 3.2 moles of carbon. Now carbon, I just looked up in the old periodic table. Nothing to it. Okay? You try. How many grams are in 4.5 moles of carbon? So pause the video, give it a try. If you look it up in the periodic table, you'll find that carbon is 12.01 grams per mole. So give that a try, guys. Okay, welcome back. We have 4.5 mole of carbon multiplied by something to give us grams of carbon. Now, this could be any element, right? We just used carbon in the last 2 examples. It could have been any element on the periodic table. Moles, grams, moles canceling. 12.01 and 1. Grab the calculator. Oops. And make that a little prettier, guys. A little bit. Not much, but a little bit. 12.01 multiplied by 4.5 is 54. 54 grams of carbon. Hey, how's that, guys? I'm sure you got it right. If not, go back and try again, review the video. Make sure you can do this. It's pretty easy stuff, but you got to know how to do it. Remember, it's all just unit converting. It's all just unit converting. All right, here's another one for you to try. So pause the video. You're going to have to look up the molar mass of sodium before you continue. So go ahead and look the molar mass of sodium up. Come back and try to solve this question. All right, guys, welcome back. Well, we have 34.5 grams. This time it's sodium multiplied by something to give mole of sodium. So put grams on the bottom, mole on the top. We got to go to the periodic table because I don't know the molar mass of sodium. Let me see here. There we go. 22.99. Oops, all my work gone again. So we have 34. We already did this part, but I'm going to do it again. Grams of sodium. Grams on the bottom, mole on the top. Make that a little prettier if I can. There we go. Equals mole of sodium. 22.99 on the bottom and the number 1 on top. Now you grab your calculator. 34.5. Divide that by 22.99. And it's 1.50. That's the moles of sodium in that mass. So that's exactly the same as all the questions we've done to this point. Only now, instead of going from moles to grams, you're going from grams to moles. You just let the units tell you what to do. The units say divide, divide. The units say multiply, multiply. But the units will tell you if you let them. So let them. Calculating the mass of a compound. We've already kind of done this. I alluded to it a little earlier. Well, let's do it again. You guys, try this one. We've already talked about how to calculate molar mass, so you guys go ahead and try this. What's the molar mass of AlCl3? You have to look at the mass of aluminum and the mass of chlorine. So go ahead and pause the video and try now. All right, guys, welcome back. First thing I'm going to do is look up the molar mass of aluminum. And let's just scroll over till we find it. There it is. 26.98. And chlorine, 35.45. All right, so aluminum, I'll type that into my calculator before I forget. 26.98. And chlorine is 35.45. There we go. Let's go back to where we were. Let's write these down real quick. Aluminum, 26.98 grams per mole. Cl equals 35.45 grams per mole. And it's AlCl3. So it's 1 times aluminum, 3 times chlorine. So it's 1 times 26.98 grams per mole, and 3 times 35.45 grams per mole. And let's do some math here. 35.45 multiplied by 3. So it's going to be 26.98 plus 106.35, and these are both grams per mole. And then add all that up. 133.33 grams per mole is the molar mass of aluminum chloride. Okay, remember, the mass of a molecule is the sum of all the masses of the elements in the molecule. So let's try another one. We're going to go right into a calculation. So now we're going to have to calculate the molar mass, and we're going to have to calculate how many moles there are. So this is a two-part question. It's a little tougher. So let's go through this together, shall we? First of all, how many moles of CO2 are there in 435 grams of CO2? All right, so 435 grams CO2 multiplied by something to put grams of CO2 on the bottom, mole of CO2 on top. There we go. Equals mole CO2. Grams cancel, leaving you in moles. So now, we don't know what number to put here. I have no idea. I'd have to look it up in the periodic table. But I go to the periodic table and I realize there's no CO2 element. That's a molecule. I have to calculate it, right? So let's calculate it. CO2, 1 times carbon, 2 times oxygen, equals 2 times 16.00 grams per mole. I looked it up in the periodic table. 1 times 12.01 grams per mole. Again, I looked it up on the periodic table. Then I calculate it. 32 plus 12.01 equals 44.01 grams per mole. So now, let me get rid of this thing here. There we go, good enough. 44.01 and the number 1, 435. Divide it by 44.01 equals 9.88 moles of CO2. So that's how you'd calculate moles from grams if you had a molecule. All right, so there we go. We'll leave it there. That's a pretty intense little section. A lot of math there. We'll come back and we'll look at the molecular shapes. Molecular shapes are a little weird, but very, very interesting. And we'll have some models to show you too on the old webcam. So when I see you again, we'll discuss that, and I think you'll be really happy with the outcome. But until then, I wish you good luck and good chemistry.